sometimes the regular rectangular coordinate plane is not the best way for plotting locations. There's another type of coordinate system called the polar coordinate system. The polar coordinate system is used in such jobs as surveyors. I don't know if you've seen, sometimes there are people on the side of the road wearing those orange jackets, and it looks like they're taking pictures. They're usually working for the civil engineering department, surveying, checking for, traffic patterns, road conditions, things like that. So what are polar coordinates? Well, polar coordinates need two coordinates, like the rectangular coordinate system, but the two coordinates they're going to use are the radius of a circle and an angle from the initial ray. In trigonometry, remember that the positive x-axis was called our initial position. So then, if you have some terminal ray somewhere of length r and angle theta, that's going to define something called a polar coordinate. Now remember that this is positive angles. If you go in the clockwise direction, that was negative angles. Some things you need to remember before we do this. Things like the unit circle whose length was 1. And then you need to remember that this is 0, 90, 180, 270, and 360 in degrees. And in radians, 0, pi over 2, pi, 3 pi over 2, 2 pi in radians. So on this graph, we're going to call that positive x-axis the pole. Polar axis, we're going to call it, because we're going to call the origin the pole. Oops, this pen doesn't want to write. Now let's talk about how to graph in polar coordinates, and I am going to draw it by hand rather than give you polar graph paper, and I'll explain to you in a minute why I'd rather draw it. So let's look at example 1. We want to plot the points whose polar coordinates are given, and I know it says use the provided graph paper, but I didn't provide graph paper. So A is 245 degrees. The way graphing polar coordinates works is first you're going to figure out where 45 degrees is. Now I realize this is backwards from the way we do it with rectangular coordinates. With rectangular coordinates, we always look for the first coordinate x and then the second coordinate y. In this case, we're going to do theta first. So 45 degrees is about here. And then a radius of 2. What you're going to do is you're going to draw 2 concentric circles. And we're going to call each circle's radius 1. So the first circle has radius 1 and the second circle has radius 2. So this is the location of the point. In B, -3, -60. Well, -60 is going to be down here. Remember, if you go this direction, that's your negative angles. And -3 means you're going to make 3 circles. But let's talk about negative radius. This point here is the point +3, -60 degrees. That's because -3 means go 180 degrees the other direction. So this is where -3, -60 degrees is. Do you have to plot both points? No. This point I just graphed for comparison's sake. You don't actually have to draw it. Let's talk about C, which is 1/2 300. I gotta move this up. This is where I don't like polar graph paper. So 300 degrees is here, which is actually the same place as -60 because they're co-terminal angles. And then in order to do 1/2, I'm going to draw one circle. Because remember that one circle is radius 1, so 1/2 would be halfway to the end of the radius. D, 1 pi over 6. Pi over 6 is 30 degrees. If you don't remember your radian measures, remember you can change this back into degrees by multiplying by 180 over pi, and then these cancel, and 180 over 6 is 30. So 30 degrees is about here, and if the radius is 1, I'm going to draw one circle and put my dot there. 5 pi over 6. 5 pi over 6 is 150 degrees. So in order to draw 1/2, 150 degrees, 150 is here. And since the radius is 1/2, I'm going to draw one circle and halfway. And then the last one is -4, 101 pi over 2. Well, where the heck is 101 pi over 2? Well, you can try to find the coterminal angle by first changing it into degrees and then subtracting 360 multiple times, but that's going to take too long. So we're going to find 101 pi over 2 a little bit different. 101 divided by 2 is 50.5. Now on the unit circle, remember this was 0 pi, 1 pi, and then this was 2 pi, so this would be 3 pi, so this would be 4 pi, and then this would be 5 pi. In other words, the positive x-axis are even pies, and the negative x-axis are odd pies. And then the y-axis were your half pies. This was your pi over 2 and your 3 pi over 2. So if I could figure out where 50 pi is, then I can figure out if it's going to be at the positive y-axis or the negative y-axis, because it's going to be something pi over 2. Well, 50 is an even number. So 50 pi would be here, so this must be 50.5 pi. So now I can go draw this. So 101 pi over 2 is here. And the radius was -4, so I'm going to draw 4 circles. And up here, that's +4, 101 pi over 2. So this must be -4, 101 pi over 2. Because a negative radius means find where the point is, and then draw the point 180 degrees away from it. Now there are different ways of naming each of these points. So we're going to talk about 4 different ways of naming each of these points on this particular polar graph. Then we're going to look at points A, B, and C, which are, so A is this green one, B is the red one, and C is the purple one. It says name 4 different pairs of angles between -360 and +360. Well, let's just start with A. A looks like it's on the first circle. Well, maybe it looks like it's on the second circle. So maybe it's on the second circle. So it has a radius of 2. And at what angle is it? Well, I don't like this, so I'm going to have to figure out what the each of the scales are. So I guess they're in tens, right? So, because this must be 10, 20, 30, so 150, 160, 170. So A looks like it's at 2, 170. So that's one way of describing it. Another way of describing it is to think about the angle as negative. So what if I start here and I go this direction? Well, if I go in the negative direction, that would be at -190. So it could be at 2, -190. Well, the other thing that could be happening is the radius could be negative. So maybe I'm 180 degrees away from it, which would be here. 180 degrees away from it looks like it's, let's see, 330, 340, that looks like it's probably 350. So if I go to 350 but make the radius negative, it would also land on that green dot. Or The angle could be negative. So if I go this way, isn't that negative 10 degrees? So it could be -2, -10. So that's 4 different ways of labeling that green point. And I probably should have used green instead of red because B is red, isn't it? All right, let's try this again. So the original red point is, let's see, 1, 2, 3, 4, 5, 6. It looks like it's R6, and it's clearly at 60 degrees. So 6, 60 degrees is one way of naming the point. The other way of naming the point is if instead of going in the positive angle direction, I go in the negative angle direction. So if I go in the negative angle direction, I would be at -300. So another way to do this is 6, -300. All right, the other two are going to be with a negative radius. So now we have to talk about what angle we would be at if we were at a negative radius. In order to have a negative radius and land here, I have to be 180 degrees away from it, which is here. So one way is to be at 240, but the radius is -6. And then the other way to do it is to go this way, which looks like it's probably at -120, -6. I said that backwards. It should be -6, -120. All right, let's go do this one more time with C. All right, C is the purple dot, and it looks like it's at, let's see, 1, 2, 3, 4, 5, 6, 7, 8 on the 8th circle, so maybe its radius is 8. And it's at 240, 250, 260 degrees. So 8, 260. So the next way we're going to label it is instead of going in the positive angle direction, let's go in the negative angle direction. So if this is -90, that must be -100. So it must be 8, -100. All right, now the other two are going to be with a negative radius. So we have to figure out what's 180 degrees away from that angle, which is going to be this one. That's at 80 degrees. So maybe I could use -8, 80. And the other way is instead of going in the positive angle direction, I go in the negative angle direction. So if I'm going the negative direction, this is -90, -180, -270, so that must be -280. So in order to name the point in different ways, you can go in the positive angle direction, the negative angle direction. Or you can find an angle that's 180 degrees away from it and use a negative radius. Next, let's look at some simple polar equations. We're going to talk about more complex ones later on, but for right now, if I want to graph r equals 3, that means I want to graph on my polar graph every point that's a radius of 3 away from the center. Well, that means I would be on the 3rd circle. So I'm going to use different, well, I'll do this. I'll use black. So here would be a radius of 1, a radius of 2. So this would be the graph. Every point on that circle would be a point on the equation r equals 3. It works the same way for part C here with r equals 5. 1, 2, 3, 4. r equals 5 would be the circle whose radius is 5, because every point on that circle would be a point in that equation. Well, then what does it mean if instead I use theta? Well, theta equals 45. is going to be a line, because on our polar graph paper, doesn't matter how many circles I draw, I'll just draw a couple circles. 45 degrees is here. Well, any point on that line is going to be the equation theta equals 45. The reason that we also use this is because, remember, we could graph here and have a negative radius. So, if theta equals an angle is a straight line, then the graph of negative 60, and again, I'm just going to draw a couple circles just to show you what it looks like. Negative 60 is down here, so the rest of the graph must be here. Let's say I want to find the distance between 2 points on a polar graph. For example, let's say I want to find the distance between 2 30 degrees and 4 150 degrees. So this would be the distance. What I want you to notice is it's not a right triangle, and I do know 2 of the sides of that triangle. I know that this side is 4 and this side is 2, and because I know what the angles are, I know that the angle from 30 to 150 is 120 degrees. Wait a second. I've dealt with triangles like that before where I have side angle side. If I know 2 sides in the included angle, the way that we found the third side was by something called the law of cosines. The law of cosines was the one where the side you're looking for squared was equal to the sum of the other 2 sides squared minus 2 times the other 2 sides times the cosine of the included angle. Now we're going to use different notation. In the book, it's the same formula, but instead they're going to call it the distance from P1 to P2, so from point 1 to point 2, is going to equal the square root of, and why did they get the square root of? They did this. The square root of the first radius squared plus the second radius squared minus 2 times the first radius times the second radius times the cosine of the angle between them. Ran out of space, sorry. And the way that you find the angle between them is by subtracting the 2 angles. It's the same formula. Let's practice. So in problem 4, I want to find the distance between each set of points. Now I really don't need to draw it unless you really want to. How about we call this R1 theta 1 and we'll call this R2 theta 2. So the distance between them is going to be the square root of the first point squared minus the second point squared plus the second point squared minus 2 times the first point times the second point times the cosine of the angle between them, and negative 50 minus 30 is negative 80. I want to remind you that we said that the cosine of a negative angle was just the same as the cosine of the angle. So the cosine of negative 80 is going to give you the same answer as the cosine of 80. And when I shove this in my calculator, I find out that it's about 684.6 units away from each other, whatever those units are. Let's try one more time. In part B, we'll call this R1 theta 1, R2 theta 2. So it's going to be the square root of 700 squared plus 350 squared minus 2, oops, I'm having problems here, 2 times 700 times 350 times the cosine of negative 35 minus 40 is negative 75, but it's going to be the same as positive 75. And then I'm going to find out that this is about 697 units apart. And that is section 9.1 on polar coordinates.